Hi students, welcome to Sri Ramanja Vidya Mandir, a temple for learning. Children, in previous lecture we have seen what is momentum and what is change in momentum, and corresponding to the change in momentum we have seen what is Newton's second law also, children. Okay, there is a relation between the force what we are applying on an object and how much is change in the momentum in that particular object. Okay, children, see here, our discussion is going on regarding Newton's second law. What Newton's second law states, children? It states that the rate of change of momentum okay, children, the rate of change of momentum is directly proportional to force applied. Okay, children, the rate of change of momentum is directly proportional to the force applied. Children, see here, rate of change of momentum. There is change in momentum, children. Change we always represent with the symbol delta. Okay, change we use it to represent with symbol what, children? Delta. Okay, change in what, children? Change of momentum. Okay, change in momentum, that is equal to what? Always we take the change or difference from final value to initial value, children. Final to initial. Okay, so final momentum to initial momentum. Final momentum minus initial momentum, that is what, children? Change in momentum. Okay, so children, here what it is, the thing is rate of change of momentum. We can represent this statement as force proportional to dp by dt. Children, in books you can see, you might have seen this one also. Okay, this also represents that with respect to time there is change in momentum. Okay, children, with respect to what? Time. There is what? Change in momentum. Okay. Children, the thing is here, the Newton's second law doesn't states that directly. It is not stating that F equal to ma. Simply we can't say Newton's second law means F equal to ma. Newton's second law is whenever there is change in momentum, the change in momentum or the rate of change in momentum is proportional to what, children? The force applied. Okay, that is Newton's second law. From that we derived F is equal to ma. Okay, children. So if we observe, F is equal to what we got, children? Pf minus Pi by T. Okay, and in the previous lecture I discussed this one, where F into T, if we take F into T, force into time, what we get, children? Pf minus Pi. Okay, Pf minus Pi. Final momentum minus initial momentum. See, children, this one is what? Impulse. What is this one? Change in momentum in specific time. The change in momentum in some specific time interval is nothing but impulse, children. Okay, it is impulse. Children, let us consider a body. Okay, let us consider a block of mass 2 kg. Some force applied on that block, children. Some force applied on this block. Due to this force, what happened? The block started moving. Okay, it starts moving and reached to some other place. Okay, children. Here, the block mass doesn't change. Okay, the mass of that particular block doesn't change. But once imagine, children, a block was kept on the floor which is not moving initially. Initially what, children? It is in rest condition. Okay, this block initially rest. Initially the block is at rest. Okay, means what will be its velocity, children? What is its initial velocity? 0 meter per second. Okay, now force applied, the block started moving. Children, it takes some time. The block move to some time, it takes some time, and then its velocity increased, children. Now its velocity increased. Okay, now its velocity, final velocity, that is 2 meter per second. From 0 to 2 meter per second. That is final velocity, children. Okay, here the time interval is there, some time. That time let us consider 2 seconds. Okay, so what is the time, children? 2 seconds. What is the initial velocity? 0 meter per second. And what is final velocity, children? 2 meter per second. Now children, see here, we need to find what is force, how much is the value of force, how much is the quantity, magnitude of force, simply magnitude of force we need to find. How much magnitude of force was applied on that particular block we need to find. Okay, children, for this purpose I am using this formula. Okay, children, here we do not have acceleration. Okay, we are not having the acceleration. So what we are doing means, first let us find what is initial momentum. Initial momentum Pi is equal to mass of the block 2 kg into initial velocity 0. So what is initial momentum, children? 0. What about final condition, children? What is final? Final momentum Pf, okay, is equal to mass of the block 2 kg into velocity 2 meter per second. Okay, children. So from here what we get? Final momentum 4. Children, see here, 4 Newton second. Sorry, children, 4 kg meter per second. Sorry, kg meter per second. Okay, children, that is what? Momentum. Okay, children, mass into velocity. Mass into velocity. Mass kg into velocity meter per second. Children, observe here. Once observe this point. Kg meter per second square. Kg meter per second square is equal to what, children? Newton. Is equal to 1 Newton. Okay. Now let us multiply both sides with S. Okay, children. So here what we can do, children? We can do cancellation. S and S gets cancelled. So what we get, children, finally? Kg meter per second is equal to Newton second. Okay. So children, here we can write kg meter per second or Newton second. What it is, children? Kg meter per second or Newton second. Okay, children. So here this one is what? Final momentum and initial momentum. What is the time, children? 2 seconds. So what we got? Initial momentum is 0. Final momentum how much, children? 4. Magnitude, just I am writing the numerical value, children. Okay. So time we have, children. Time is 2 seconds. Okay. So what is force, children, now? mv minus mu, or simply we can write like this, children. Change in momentum by time. Pf minus pi by time t. What is Pf, children? 4. What is pi? 0. By time is 2. Okay. So 2 newtons. How much is the force, children? 2 Newton. Okay. 2 Newton. Children, keeping the time constant, let us increase the final momentum. I am not changing the time, children. Keeping the time constant. Okay. Time t equal to 2 seconds. Initial momentum also I am not changing. 0. Okay. But final momentum, I increase it, children. Just consider, let us increase it to 4 Newton second. Okay, children. 4 Newton second. So from here what we can write, children? What we get for force? Force value will be what? 8 minus 0 by 2. Means how much, children? 4 Newton. Okay. So F is equal to 4. Children, once observe here, when final momentum is 4, force is 2 Newton. When final momentum is 8, force how much, children? 4 Newton. Means what happened here? As soon as the change in velocity, change in momentum is more. Here how much will be the change in momentum, children? How much will be the change in momentum? Delta P is equal to 4 minus 0, that is 4. Okay. Here how much will be the change in momentum, children? Change in momentum equal to 8 minus 0, that is 8. From 4 to 8, what happened, children, here? Change in momentum is more. Okay. Change in momentum more. Change in momentum increased. What about force, children? Here it is 2 Newton, here it is 4 Newton. Means force also increased. Okay. And one more point, children. When the value of the momentum increase, at which condition? The momentum of that particular object increase, children. At what condition? Here we know that momentum is equal to mass into velocity. Mass anyway constant, children. I am not changing even the mass. I am keeping the mass constant. Keeping the mass constant, how we can increase the momentum, children? By increasing the velocity. Okay. By increasing what, children? Velocity. Keeping the mass constant, I increased velocity, children. That's it. Such that momentum also increased. Okay. That thing I applied here. Okay, children. So here what I changed? Velocity. Velocity increase. Okay, children. So what we can say, children, from this? Whenever keeping the mass constant, if we increase the velocity of the block, definitely the force created due to that will be more. I am saying this one in reverse manner, children. Okay, I will give you one example. Here a ball is coming, just here 2 persons are there, children. Okay, this fellow thrown a ball and another person is about to catch this one. Okay, is about to catch that ball. Next, another case, children. This same fellow, now a ball there, children, which is at some height. the ball at some height, children, okay, and it is coming now. Here is that fellow and he was about to catch. Once observe, children, in these two cases, okay, from here to here, okay, and from topmost point to down, in which case the velocity will be more, children, in which case the velocity will be more? Obviously, in this second case, the velocity will be what, children? More. Okay, more velocity. Okay, so since the velocity is more, what will be more, children? We have seen now. Change in momentum will be more. Change in momentum will be more. Since the change in momentum is more, what will be more, children? Force exerted by that particular body will be more. Since the force exerted by particular body is more, here in this case, this particular person get damage. Okay, experience severe force. He may get damage also. Okay, here the speed is less and change in momentum is less and force experienced by this person also less. Since the force experienced by this person is less, okay, the injury, the rate of getting the injury is less, children. In this first case, injury will be less, and here the chance for getting the injury will be severe. Severe cases are there. Severe injury may get, okay, more number of chances are there. Okay, children. So that is the reason you might have seen when you are about to catch, while you are playing the cricket, when you are about to catch a ball which is coming from certain height, you feel more force got exerted on your palm. You may get pain also. Sometimes you get pain. Normally if you catch, nothing will happen. Okay, but from more height, if you throw any object, from more height, if any object is falling, the speed whenever it is coming down, we know that, children, I said these points in your earlier classes, earlier lectures. If an object coming from topmost point, its speed gradually increase. Since the height is increased, the speed with what it is coming also increase. Potential energy relation. In previous lectures I said. Okay, so due to that, what will happen? Whenever the speed increase, what will happen, children? Here we got. Since I already said that, here I am increasing the speed. Since the speed increased, what happened, children? Momentum increased. Since the momentum increased, what happened, children, here? Force also increased. Numerically, this is the proof, children. What is the chance? Okay. So, children, okay, we understood that when the momentum is more, okay, when change in momentum is more, the force exerted by that particular object also more. Fine. Children, see here. Now you need to decrease that force. Okay, you need to decrease that force while you are catching that ball, while that ball is coming. When it is reaching to the palm, that much force the hand was not made to catch that much of, not made to bear that much of force, children. Definitely some damage may happen. So before reaching to the hand, we need to decrease the force. Speed anyway we can't decrease. We can't decrease the speed. Okay, just imagine you are playing the cricket and the batsman, he hit the ball to the topmost point, and from topmost height, the ball reaching to your palm. Okay, you need to catch that ball now. Okay, so when it is coming down with some certain height, definitely speed will be more, children. Okay, whenever speed is more, obviously force will be more. Now with that much of force, if that keeper, if he catch that ball, definitely he will get damage. But in order to avoid that damage, what we should do, children, we need to decrease the force. How we can decrease? See, children, we have a relation. Force into time is equal to change in momentum, Pf minus Pi. Okay, Pf minus Pi. So, children, one see, from here what we can write? Pf minus Pi is equal to F by T. Children, this case, when that ball is reaching to the palm, let us consider this is the surface, children, where it is about to fall, okay, and the ball is about to hit this palm, okay. It is coming with some force. Decrease this force now, okay. How we can decrease the force, children? Okay, force must decrease. We can't change this value, children. Pf minus Pi, we can't change. That is not in our hand. But what we can change? The time. Okay, this time, see children, F and T are both inversely proportional. If we take this one as constant, force inversely proportional to what, children? Time t. So you need to decrease this force. Okay, so what we should do? We need to increase the time. What is this time, children? Here, this time is called time of impact. Okay, so time of impact in the sense, children, when this object is touching this surface, up to how much time it will be in contact with this surface, that is called time of contact. Okay, children, simply suppose when you are catching that ball will touch your palm. Up to how much time it will there in your hand, that is called time of impact. Okay, so that impact you need to decrease. That's why what we will do means, instead of catching like this, we pull the hand back. See this point carefully, children. Okay, the time of impact, okay, within what time that ball will reach to our palm, within what time that ball will reach to our palm. Okay, that time we need to decrease. Okay, so what we will do, children, instead of catching like this, we will decrease the hands. Okay, the distance we will decrease. We will catch like this. Okay, so here what happened? The time of impact decreased. Instead of catching here, we will drag up to here. Understood, children? Instead of catching at this point immediately, we will drag up to some time, so that the time of impact will be more and the force experienced by our hands will be less. Okay, children, very, very important thing this one. Okay, time of impact in the sense, the time in which that object with coming with some force will hit our palm. If we can decrease that time, if we can prolong that time. Impact in the sense what, children? Impact means the force at the time of means the force whatever is exerted on the palm, that is impact. That one we need to decrease. Okay, so what we are doing, that impact time means the point where it will reach our palm, that time we will decrease. How we can decrease? By lowering our hands. Okay, children, so that the time taken will be increased and force experienced by the body will decrease. So that's the reason every time while you are playing cricket, when you are about to catch a ball, you will lower your hands. Understood, children? So the force anyway we can't stop. We can't stop the force. When we are about to get the ball, the force experienced by that ball we can't stop. It will definitely come with the force. Okay, that one change is nothing but what? We said that change in some momentum. Okay, that one we can't change. The force whatever that's gonna means that is about to exert on our palm, that we need to decrease. That object, from that object we can't escape. But what we can do, children, alternative, the force that is coming from that object we can decrease. Okay, while you are playing, your job is to catch that ball. You can't leave that one. But without damage, you need to catch that ball. Okay, so immediately if you catch like this, the time of impact in the sense at the what time the ball reached to your palm, that time if you can decrease, that time of impact if you can decrease, the force means that not decrease, children, we need to increase. The time of impact we need to increase. Okay, so instead of catching at some higher point, if we can lower our hands, okay, we are increasing the time of impact. Okay, increasing the time of impact such that from this relation the force will decrease. Understood, children? So anyhow, means not only here, children, I already discussed, while you are playing, while you are going on road, speed breakers will be there. You need to move over that speed breaker. Suddenly you will experience that impulse force. In order to decrease that force, what we are doing means we are using suspensions, children. Okay, like these suspensions will be there, like a spring arrangement. Let us consider the wheel. This one is wheel, children, which is in contact with the ground, and this one is the place where you sat. Okay, so when it is about to go over a speed breaker, what will happen? Definitely it will give you some impulse, some force. That force will directly reach to the seat and that person will fly. Okay, instead if you can provide this arrangement, this spring arrangement, what will happen, children? The force after coming here, it should travel this entire length of the spring. The force will travel around this length, children, and it will reach here. Okay, anyway it will reach to the passenger. Okay, the force experienced by due to that speed breaker, anyway that force will reach to that passenger. What we can do, we can increase the time of impact. See, children, here immediately the force reaching to the passenger, so time is less. But here the force is making so many turnings, it is taking so much of time. We are increasing the time here by keeping the suspension. Since the timing is more, what will happen, children? The force will be less. Okay, children? So this is the case. This is the purpose for what we are using suspensions for the vehicles. Okay? Due to the suspensions only, most of the time we are not experiencing that impulse. If those suspensions only not there, at each and every time while you are moving over the speed breaker, uneven roads, definitely you will experience what? Impulse force. Force due to impulse. Okay, children? Very, very important. Basing on this concept, I am going to give you some problems also. Okay? So what is the conclusion, children, here? The force due to change in momentum. Okay? See, children. Here with some force you projected the ball. Okay? And while going to the point, it will go to some highest point, this ball. It will go to some highest point and again it will reach to some other person. While it is reaching to this some other person, what will happen, children? The momentum will change. The momentum of this ball will change from starting to ending. Due to this change in momentum, what will happen, children? This is going to exert some force. You need to decrease this force. For that, what this person will do, children? He will increase the time of impact. That is the only way you can avoid impulse. Force you can't escape, children. You can't skip the force. You need to experience it, but with less quantity, less intensity. How we can make sure the force is less? By increasing the time. Okay, children? Very, very important. Okay, students. So this is regarding impulse. Okay. So what we understood, children? Whenever we are increasing the time of impact, the force experiencing by us will decrease. Okay, children? So the next one, children, Newton's third law. What Newton's third law states? Newton's third law states that for every action there will be equal and opposite reaction. Okay, children? What it is? Newton's third law states that for every action there is equal and opposite reaction. Children, here whatever it is, action or reaction, it is nothing but force, children. We were talking about force. Action is also a force and reaction is also a force, but The thing is, both will act in opposite direction. Okay, children, simple example. That is well known, children. For every action, there is equal and opposite reaction. Suppose if you beat any wall, any rigid body, any wall or any strong item, if you beat, you will experience some pain. Okay, at your palm, you will experience some pain. Okay, children, in this case, you are applying action, the force what you are applying on that particular body at the first thing, children, here. Okay, you are applying force on that wall. Children, let us consider a wall. Okay, so children, see here, any wall or any rigid strong support. Children, see, take a ball, children, take a ball, okay, a tennis ball, cricket ball, anything, which is having some elastic property. Okay, for only explanation purpose, children. So here, whenever you are throwing the ball against the wall, okay, you are throwing that ball against this wall, children. When you are throwing like that, what will happen? This ball is applying force. Okay, let us consider that one as action, children. Force due to what? Action. In which direction, children? Towards the wall. Okay, it is acting on the wall. Children, after throwing, what will happen? That ball rebounds. Okay, without any force, it can't rebound, no, children. Without force, it can't rebound. Okay, so what this wall will do? This one will apply this one also apply force on that ball, children. Okay, with same force. Okay, with how much force the ball applied on the wall, that much of force that wall also apply on the ball, children. Okay, ideally with the same force. Same ball, children, same size. There is no change in size of the ball. There is no change in the shape. Okay, everything is same. And even the magnitude of force also same, children. The magnitude of force also same. Okay, but only thing is, this one is reaction, force due to reaction, and this one is acting in the opposite direction. In which direction we are throwing, okay, in opposite direction to that particular direction, reaction will act. Okay, children, so here, what is the first thing? Ball applying force on the wall. Okay, so this one is what? Force due to action. And the wall also applied force on the ball, children, in the opposite direction. So this force. Here this one is action, children. This one reaction. The only thing is, children, here magnitude is same. Okay, the force which was exerted during the action and the force which was exerted during reaction, both are same magnitude. That magnitude is same, children. But only thing is, direction will change. Okay, so not direction will be opposite, children. Complete, quite opposite. Okay, so here what will happen? Force due to action is equal to force due to reaction, children. But the only thing is, here minus will come. This minus represents what? Opposite direction. Okay, children, that minus represents opposite direction. Okay, children. Here this one, suppose if you are beating the wall with your hand, okay, you might think like this. The ball is repelling like that, but why your palm is not repelling? With how much force you are beating onto that wall, with the same force, why it is not rebounding? Okay, children? You might think that same reaction force we are not getting. You don't think like that. Okay, even when you are beating also, even your hand is not made of elastic property also, you will experience the reaction force in terms of pain. Your hand suffers some pain. That pain is created due to what, children? That reaction force. With how much force you will you beat that wall, that much of pain you will experience. Okay, don't experiment. You can think it like that, like this. Okay. Normally, that is a general common sense, children. With how much force you are beating the wall, that much of pain your hand will experience. Understood? Okay. So let us consider not hand, children. Any object, any plastic water bottle. Okay, water bottle. Normally, if you tap like this onto the wall, against the wall, nothing will happen. Just some sound will come. That the shape of that particular water bottle may change for slightly. It may change. But if you apply more force with that bottle onto the wall, what will happen, children? More reaction force also will come, and that bottle will break. How much force you are exerting onto the wall, that much of force will be experiencing by that particular object again. Okay, children? So, always action and reaction occurs with same magnitude. Okay, children? So, here we are discussing about action and reaction in terms of force, children. Action is also a force, reaction also a force. Action is force, reaction also force. Both are in same magnitude. Both are in same magnitude. Magnitude in the sense, children, you can consider like this. Like here this one is 20 Newton. This one also 20 Newton. Okay, but thing is what? Minus will come. Minus 20. Okay, children? Yeah, see here. Now I gave this one as an example. Children, this one equilibrium. Equilibrium in the sense the upward force on the balloon and downward force both are equal. Okay, the upward force and the downward force both are equal. So that is the reason the balloon is able to stay in equilibrium. As soon as this person release that entrance, see, children, the space through which the air enters into that balloon, if he opens that, instead of closing, if he opens, if he leave, what will happen, children? This one, that air, whatever there inside that balloon, will exert some force. Okay, children, that force will act downward. In which direction the force acts, children? Downward. That is force due to action. Action. Okay, same set of same magnitude of reaction also come now, children. Okay, reaction force also will come with same magnitude. Okay, children. So that one acts in which direction? Upward direction. That is force due to action. Okay, children. So due to this condition, what will happen? How much force that air is exerting downwards, with same force will be exerted upward also, children. Opposite direction. Okay. So here the direction is opposite. Suppose if this downward is action, this one is reaction. Okay, children, action and reaction. Due to this, the balloon is able to move up. Due to that reaction force, balloon is able to move up. Not only this one, children, you can even consider rocket. I already discussed regarding that one. Next, see, children. Now only, just now, I explained this. This person is trying to apply force with his finger on the wall. Okay, what will happen, children? This one is action, children, against the wall, onto the wall. Okay, that wall also exert force, no, children? This wall also exert force. That is due to, that is what? Reaction. That reaction also a force which is experiencing by that finger. Due to that, that person will experience some pain. Okay, children, let us see here. This particular hammer, okay, this particular hammer applying force against this wall. That hammer applying force on the wall. Okay, children. So this one is what? Action. Children, once observe, if you are beating with hammer against any object, definitely that hammer rebounds again. It rebounds back. Okay. When you are hitting like this, again that hammer up to slightly it will come back. That is due to what, children? That reflection is due to what? Reaction. Force due to reaction. Okay. When you are beating with hammer onto the wall, what will happen, children? That hammer exerts force on the wall. That is action. Same force, that wall also returns to the hammer. That's why it comes back. That is reaction. Action, reaction. Okay, children? That is in which direction? Action is in one direction, reaction in opposite direction. So both will be in opposite direction with same magnitude. Okay, children? That's all for today's lecture. And another important and interesting topics are there, children, that will be discussed in our next lesson, next lecture. Okay, children? Until then, thank you and have a nice day.